So, hi again, and thanks for another opportunity to join sambaXP in person. It's great. The last time I was here was 2023, where I surprisingly was invited to deliver the keynote. And then we went virtual last year, and so here we are back again, and it's fun to be back. I'm really, I don't know, honored and happy to be back in Göttingen for this. I love sambaXP. I've been coming to it for, I don't know, over a decade. Just about a decade, maybe. No, well over a decade. I think my first sambaXP was probably 2010. So anyway. I talked about this before, and I guess it was reinforced by Volker's presentation last year at sambaXP that he later did at SDC, where he compared SMB and NFS in a very detailed fashion. And I found when I was listening to Volker's presentation that I said, I agree with everything he says, and I probably have a few things to add. But, you know, it's interesting. It doesn't draw necessarily a conclusion, but it lists a lot of interesting things. And so I said, I don't know if I have a conclusion either, but I think there are other useful and important ways to look at it. And I view it more as an example for possible direction for SMB development, rather than a sort of instructions or a wish for SMB development. It's something that has to be thought about. I apologize, my voice is already getting a little hoarse. I may have to pace my presentation a little bit. Anyway, I just want to start with a definition of what I mean by the words NFS4 and SMB3. You know, there are a lot of different versions of each one. By NFS4, I mean NFS v4.1 and greater. 4.1 is widely implemented, though it's not universal. It's not used by anywhere near, maybe not even a majority of the NFS user population. NFS 4.1 and 4.2 are largely the same protocol. 4.2 adds a number of extensions and some protocol corrections to NFS 4.1. And if you negotiate 4.2, you can issue NFS 4.1 for free. It's always downward compatible, the NFS spec, in the NFS 4 space. NFS v3 is the main competitor to NFS v4, right? And NFS v3 has been around forever. I'm going to mention it in my next slide. It's still in use, but it's not going to be a focus. It's not a focus for the future. It's certainly not a focus of my talk. NFS v4.0, I think is important to mention, is deeply flawed. It was a good first effort, but it's a flawed protocol. It doesn't work properly in an internet environment. It was intended to do that. It was intended to be NFS for the internet, but it fell short. It also was intended to be NFS for multiple types of operating systems, right? It foolishly decided to specify an ACL, for instance. That was an introduction to defeat. You know, ACLs, that's the only thing I'm going to say about ACLs today. Anyway, so think about 4.1 and 4.2 when I say the word NFS v4. I don't want to keep spelling it out. For SMB3, I mean 3.1.1 with all the optional features right up to the latest version, right? The interesting thing about 3.1.1 is it's the benchmark version implemented by Microsoft in Windows. And Windows inevitably moves forward, you know, keeps the world moving forward with it. And it sets the benchmark for SMB3. It's 3.1.1. Widely implemented, it's just simply the default. Windows always negotiates the highest protocol, so it's just what you get. Doesn't matter, it still interoperates with all the other versions of SMB3, but just think of the tip of the spear, if you will. And the final definition, at a sufficiently high level, both these protocols, or protocol families, have one goal, and the word is sharing, right? It's file sharing, but it's sharing. It's the accessibility of information in whatever container it happens to be stored in on a shared network by shared, possibly cooperating, possibly independent clients, remote consumers. Sharing. That's the key word about all network file systems. It's easy to forget. People think it's about files, right? No, it's not about files. It's about sharing. A little bit of my history. I mentioned this when I gave my keynote, but I just want to show that I think I'm a rare bird. People tell me I'm a rare bird because I have excellence in both NFS and SMB. It's fairly uncommon in the industry. I think, others in this room have that same experience, but I think you'll realize that there are very few of us. It's a handful. We all know each other. There's a bunch of users who use both, but developers who are really in the guts, who wrote the specifications, who implemented the implementations, it's a small number. It really is. My first NFS implementation, which I spelled wrong, silly me, implementation, was back in 1989, believe it or not, 36 years ago, I hesitate to say, where I wrote a NFS4 client for our X11 terminal, and I took it to Connectathon. I showed my badge from that year in my keynote 2 years ago. You can go look for it. I didn't repeat it here. So my NFS background goes back 35 years. But I was a user of NFS at the time. A couple years later, in the early 1990s, I was invited to join the NFS4 spec team, and there were about a dozen of us who wrote what became the NFS4 protocol document, published in 1995. I found my name in the acknowledgments. I'm down there with a bunch of other people. Most of those people I worked with later in my career and still do. So that's pretty interesting. I co-authored the NFS RDMA protocol with Brent Callahan of Sun at the time and implemented it on Linux 2.4. So NFS RDMA went into Linux 2.4 around 2007. I'd been working on it for a couple of years before then. And another thing that I'm particularly proud of is the NFS v4.1 session, which was a real problem. We needed it for RDMA, and we used it in a protocol called DAFs. The session was an abstraction of the transport, if you will, but one which provided for reconnection, for differing transport types to be used, all these types of things. And it was very difficult to stitch it into NFS v4 because of the minor version requirement. You couldn't obsolete anything, and you couldn't make anything required. You had to sort of seamlessly slipstream new features into the NFS v4 stream. And I absolutely, found a way somehow to slipstream the session into NFS v4 as an optional feature. But it was so compelling that it was adopted as a required feature in 4.1. NFS actually broke its own rules and made it required. So I was particularly proud of that. It enables a whole lot of stuff well beyond RDMA. SMB3, I joined the SMB3 party relatively late in 2009. Late in my career, I've retired since I worked for Microsoft, right? That was my last paid position. But I joined Microsoft to implement Microsoft's commitment to open protocols, right? It was not Microsoft's choice to document its protocols. It was forced to do so. But it made a true commitment to it. I talked about that a lot at my keynote. The documentation had other benefits. It improved the protocol itself, right? When you write it down in a normative way, you better get it right. You find a lot of bugs when you do that in the actual architecture and specification. And it improved Windows. It made Windows work better. For one thing, there was a reference that people could look at and say, what should it do? And there it was. For another thing, it enabled innovation in Windows, right? By making it not just a Microsoft thing, but opening it to the industry as a protocol spec, it got better, right? The industry told Microsoft, this isn't right. We wanted to do more or less or whatever. And Microsoft, in turn, owned it now, right? It isn't just for Microsoft's benefit. It's for a broader benefit that benefits Microsoft by the nature of others using it. It's open source, right? Although it's not free necessarily from Microsoft. It was still an open source effort. And everything got better. So it got renamed as 3.0. Maybe I have a t-shirt that says SMB 2.2, and I have the same t-shirt that says SMB 3.0. It's kind of fun. You can't wear them both at the same time, but you know, it was the same protocol, but everybody said, whoa, this is a heck of a lot bigger than a minor version. And I co-authored the SMB direct protocol. I brought RDMA over there on the left to SMB over here on the right. And that was really fun, and it went way faster, way better. So here's an oversimplified view, desperately oversimplified. But there are 3 boxes on the top, API, protocol, and file system. And there's a little box that you can hardly read because I couldn't get that font to fit without doing ridiculous things, that says transport, that light blue to the right of the protocol. And the transport is tightly linked to the protocol, and it's an important differentiator. You'll see it appear a couple times in the discussion that I have coming up. Anyway, I'm going to use this format on a lot of slides. I'm going to put SMB3 on the left. I'm going to put NFS4 on the right. There's one slide that flips them. But they all have a signature set of APIs, a signature set of protocols. It's not just the core protocol. And they serve files from a file system of some kind. SMB actually has several APIs, right? It supports Windows very, very faithfully. But it also supports POSIX with the POSIX extensions, and it supports interprocess communication, right? IPC dollar, RPC style. And the same protocol, the same fundamental protocol, is servicing multiple APIs, kind of out of the box. NFS, on the other hand, is POSIX. In fact, it's POSIX all the way through the stack. It's an API, it's a POSIX API. The file system, the protocol implements POSIX semantics in a, I mean, it abstracts POSIX as POSIX. It's the best way to say it, right? It tries to be file system independent, but it winds up being POSIX. And of course, it takes a POSIX file system. Anyway, the protocol is pretty simple. I'm just going to fill in the box with SMB3 or NFS4 as it goes. The transports are slightly different, but not very different. SMB supports TCP traditionally, RDMA and QUIC now, right? NFS pretty much just TCP and RDMA. There's an SCTP binding, but nobody really cares about it. The file system on SMB is probably the biggest differentiator. Even though the API and the protocol are rather faithful, the file system is variable. There's a lot of different file systems behind SMB. And there are a lot of different file systems behind NFS too, but they're all POSIX file systems. They're basically pass-through operations from NFS to the file system on the right side. Whereas in SMB, there's a lot of translation going on. There's a lot of file system abstraction going on. So that's kind of an important differentiator. And I want to add these green boxes, side protocols, that originate from 2 places, right? They originate from both the API and the protocol. From the API, they have to do with management, DFS, stuff like that. When you can expressly invoke a side protocol. In NFS4, the side protocols were really important, right? NFS4 doesn't do locking, for instance. You have to do all your locking through this side protocol called NLM. And so it originates directly from the higher level API, not just open, close, read, write, but how do you mount a file system? How do you query a file system? How do you manage a file system? Things like that. Side protocols also emit from the protocol itself, right? So, a redirect, for instance, may consult DFS. The application never expressly requested it, but the protocol to complete the operation goes off and does something. And so these side protocols get kicked in. In NFS4, the side protocols are mostly integrated. They're all in one spec, right? The locking, the migration, the FS locations, all these things are all built into the NFS4 protocol. In SMB, they're part of the protocol in a reference kind of a way, but they're distinct, separate protocols structurally. So there's a lot of cross-references between the specs in SMB, and there's a lot of monolithic documentation in NFS. But even then, there are true side protocols, like Kerberos, for instance, it's used by NFS. You could call it a side protocol, but it's emitting from the protocol operations. So just a quick trip backwards. When I was preparing this presentation, I thought I had a lot of great new ideas that I wanted to share. And I just wrote them all down, and I organized them. I made a bunch of slides in an outline format, and I started down the path. And I said, Volker's presentations are really good because they have a lot of nitty-gritty details and things like that. I got to be able to pull in some of those. I started pulling all this stuff together, and I realized all of a sudden, wait a minute, I'm not saying anything new here. I still don't think I am. If I say anything new and enlightening, I'm sure I've said it before. And I want to quote myself in 3 slides, just real quick, from my keynote, what turned out to be the keynote. I didn't intend it to be a keynote, but in sambaXP 2023, I presented these slides. And, maybe I could repeat them harmlessly, but I'm not going to. I'm not going to repeat myself. And I'm definitely not going to repeat Volker. That's, his content, his contribution, and I'm not. I agree with it, but there's no need for me to repeat it. So I just want to mention a few things that I always found special about SMB3 that were different from other protocols and other similar protocols all at the same time. SMB3 is not a file system, but it's deployed as one. Right? NFS is a file system, right? NFS has a file system API, and it accesses file systems. SMB doesn't have a file system API necessarily, and it doesn't access file systems necessarily. It's deployed like a file system, and it's used like a file system, but it's a whole lot more. It's structurally, architecturally not intended as a file system. It's an authenticated recoverable, it provides an authenticated recoverable session for issuing requests to peer servers. NFS doesn't do that. It has a thing called a session, but it's really kind of an abstraction of the transport in NFS. It's intended to provide a handle that allows operations to flow from client to server, and it can kind of recover itself, but nobody has implemented a recoverable session in NFS4 yet. Everybody wants to, but nobody's done it. It's been done in SMB3 a couple times, several times. The session is different. That's all I want to pull away there. It has flow-controlled synchronous or asynchronous, and asynchronous means cancelable. NFS4 never cancels, and NFS4 is never really synchronous, or never really asynchronous. I'll talk about that in a sec. But in NFS4, we have this what I hate. It's called NFS4 error delay, which means, try again later. I'll talk about it in a sec. SMB kind of does that, but it says, I'm busy, be patient. That's very different from NFS error delay, which actually terminates the operation. SMB has native integrity and or, maybe both of them together, encryption, and it's per user and per session. These are very different from NFS, right? NFS, it has native integrity and native encryption, but only if you invoke a specific type of authentication via curb 5, I, or P. And it's not necessarily per user. In fact, it rarely is per user in reality. It's per machine very often in NFS. And shared encryption is always bad, right? Because if you crack Coke, you've also cracked Pepsi, and Coke might spy on Pepsi because it has the key, and all these types of things go wrong when you share encryption. Very bad. It's many-to-many. It's extensible by design. I'm going to talk about those in a minute. What's different from NFS? NFS is POSIX all the way down. Has a POSIX API, POSIX protocol, POSIX file system. No pipes. ACLs are futile. I mentioned ACLs again. I shouldn't say that word. That's because there's no POSIX ACL that everybody agrees on. There is a POSIX ACL draft, but everybody hates it, right? Everybody likes their own ACLs. Nobody likes anybody else's ACLs. Guess what? You put ACLs in the protocol, you're dead. Nobody wants it, right? Because you have to inherit somebody else's ACLs. NFS is hard to extend by design. I want to talk about that some more. And SMB's RDMA support is better, but that's okay. Second time's the charm. And third, defining a protocol. I just wanted to remind that this is a picture of the NFS protocol, of the SMB3 protocol, SMB2 by doc name, but SMB3 by actual version. And it's these natural, non-obvious boundaries. And you can see that there are side protocols, around the clock, serve S, RPCE, DFSC, Spinago. But the core protocol links to them, references them, doesn't implement them. And the transports live below it, where the protocol talks to peers. NFS v4 tends to take all those gray boxes and mash them all together. Not so much the management, that's out of scope, but it performs its own references, its own location references, for instance. It does not do RPCE. It requires Kerberos authentication for the most part, for anything sophisticated. So anyway, I already said this, and I just want to remind people that I said it, in case you were here. Okay, pausing for a moment. This is where we enter the picture, or the two-column format. High-level semantic differences. I've already talked about this, but SMB3 supports Windows really, really, really well, right? It was designed as part of Windows, implemented as part of Windows, will probably always be part of Windows in one form or another. Has a very important role in externalizing or exporting Windows semantics to applications. It also supports POSIX. The new POSIX extensions, faithfully being implemented by various clients and various servers. 3 to date, all right, the SMB Linux client, along with the Samba server and the KSMB daemon, all support the POSIX semantics. And the POSIX semantics are really important for providing a faithful pipeline for the API to flow from client to server, right? How they're processed on the server is a server question, but getting that request faithfully to the server is the job of the extensions. So that's really important, that second bullet. And then the final bullet, IPC, RPC, it kind of just uses SMB as a transport, but where it really shines as a transport is that it's authenticated and protected, right? So the IPC can share in the same infrastructure that protects all the other client requests for file storage operations. And that turns out to be really helpful, particularly with respect to the authentication and protection, right? The same connection, for instance, can be used for everything. I didn't get to the NFS. NFS v4 supports POSIX all the way down, right? Which is great, right? Linux loves POSIX. Linux needs POSIX. But it's all the way down. And that becomes a problem when it comes time to teach it something new. And that's what I want to talk about as well. Second set of differences, the file systems. There are kind of two levels of file system abstraction going on. One is the file system itself that's being exported, and the second is the way it's being exported by a share in SMB3 or an export in NFS4. But the basic file system, SMB faithfully supports the Windows native file systems. They all resemble one another. You know, they have a lot of differences, but they all accept the same basic API when you run them natively on Windows, right? They may or may not support ACLs. They may or may not support accurate timestamps. They may or may not support resilience and all these other things that the Windows file systems do. But SMB carries them through rather faithfully. So it works really well to Windows-style clients and Windows-style servers. But it also supports non-Windows or non-rich file system implementations by freely returning not supported when something is not supported. It's almost part of the protocol. It just says if you can't do it or you have an option to turn that off, just return not supported. And it's an unequivocal statement from the server to the client that this is not available. And the client has various ways of doing that, just like a Windows application would if it were opening a file on a FAT file system versus REFS, you know, kind of two extremes of the thing. But the basic creation of a handle, manipulation of the handle, reading and writing bytes from the handle, all those things work pretty much transparently. If you try to create an extended attribute, you try to change an ACL, well, oops, you know, you're on a FAT file system, you can't do that. Well, okay, I'm prepared for that, and I know that it happens, so I'm prepared. And of course, SMB has a really interesting file system called IPC dollar, right? It's a share. It's not truly a file system, it's a pipe FS. But it has a very different semantic, right? You can read and write. You can perform some very simple transactions where you read or you write and receive a response in return. But you know, that IPC is part of the spec and conforms to the expected API. It too is optional. You don't have to have an IPC dollar, but it's there. NFS4, on the other hand, pretty much has a Unix native POSIX file system behind it. The exceptions are things like re-export, which nonetheless is another NFS4 file system, and to a certain extent side protocols that I mentioned before, but I'll mention it more in a sec. But it's POSIX all the way down, meaning you have a POSIX API, you have a POSIX-aware protocol, you have a POSIX file system. And of course, POSIX has optional stuff too, but it's still fundamentally POSIX. It's fairly tightly defined. It has some really odd, unexpected behaviors sometimes for some operations, but they're all very well defined. So you know what you're getting. As an application developer, you know exactly what you're getting. You don't have to deal with not supported very often. It's known quantity. More differentiators. Identity, authentication, and security. SMB3 exposes SIDs, Windows native security identifiers, as its identities, right? You got a SID. Your user has a SID, your file has a SID, or requires a SID for access. And, you know, everything's done via SIDs. That's its native behavior. So it's very simple, very regular. Everybody knows what it takes to authenticate. Per user tokens, that I thought I changed that word. Everything's per user, right? your encryption keys, for instance, are derived per user on Windows and under the SID model. You can be part of a group and share a key, obviously, but it's per user. It's not chosen by the administrator for you. It's assigned to you, and it's only you who get to use it in practice. That token, that key, whatever it is, whatever the secret or the capability is that you use to access any resource in SMB is always per user. A number of ways to receive that key. You can do good old NTLM, right? You log in as so-and-so, and you get a secret for so-and-so, and off you go. Active Directory or other more sophisticated identity management systems are perhaps more the norm, certainly much more the norm in clouds. It's obviously not regular Active Directory, it comes Azure Active Directory, but these infrastructures for this authentication and negotiation of the authentication method are all provided by Windows. They're all built into Windows. So an SMB3 or a Windows application pretty much has them already. And the whole stack of tokens and SIDs and authentication methods are all matched, if you will, to the native file systems. They all work very well on Windows. So they're extremely well tested, extremely well accepted by the user community. They just work. You deploy this thing, you set it all up, you log into the system, and poof, you have access to the file even if it's not local. That's not always the case with NFS4, but in a managed environment, it can be made to be the case. But NFS4 has kind of, multiple ways of doing the same thing. The token depends on your authentication method. AuthSys, by far the most commonly used one. It's the most like NTLM, right? You have a traditional user ID extracted from password that you got to use because you knew the password. It'll never die. It's easy to deploy, works great in controlled environments. Everybody uses it. There's a new one called AuthTLS. It's about 2-3 years old. It's being implemented. It has been implemented in Linux. It's an auth flavor, believe it or not. It basically says, if you can do TLS, please secure my connection with TLS. And so NFS uses it slightly preferentially, although I think it's limited in deployment right now. It's available. A lot of people are using it. It's TLS with a machine key, right? The key is not linked to your user identifier. It's linked to your machine, just like you would with an ordinary TLS connection from your browser or whatever. So it's handy, but it's pretty basic. It kind of checks the box. If somebody says, you've encrypted your traffic, right? Everybody can say, yep, I've encrypted my traffic. I didn't have to deploy Kerberos to do it, but I've encrypted my traffic. And it's not really the same, but it's encrypted. It checks the box. Whoop-de-doo. And then there's AuthCurb, full-blown AuthCurb. Kerberos 5i and 5p are the common ones, right? Integrity and privacy protection with Kerberos. You got to install your own Kerberos. NFS doesn't help you with that. And there's some Kerberos setup requirements for NFS. The user principles and things like that have to be set up rather carefully. But it can all be done, and it is done frequently. It works quite well in large installations. But there's a flavor. NFS, once again, it's defining its own methods, right? It's not inheriting methods from the system it's running on. It's defining its own methods. And that's awkward. That's the difference here, right? It's awkward. Another big difference, since I'm a transport guy, my background is in networking. Before I even understood what an RPC XDR.X was, I was a TCP developer. So I come at NFS from the bottom, not from the top. I'm not a file system guy. In fact, I'm totally agnostic as to file systems. They all support TCP, of course. SMB3 uses RFC 1001, 1002. NFS actually uses those framings. So they're pretty similar in terms of their raw use of TCP on the wire. They both support RDMA. I did them both. So I literally wrote both protocols. So they are the same at a high level. SMB3's RDMA is implemented via a framing layer called SMB Direct. NFS4's RDMA is not a framing layer at all, but a sort of a alternative encoding of the TCP encoding in RDMA, where it extracts certain blobs from the packet and marshals them for RDMA, and leaves all the other blobs, objects in the XDR encoding in line. SMB does the same thing, but much less explicitly, much more in a framing layer rather than in a encoding layer. If you know what I mean. It's like SMB attempts to wrap the packet. NFS4 actually rearranges the packet. NFS4's RPC RDMA is good, but it's somewhat bound by legacy XDR. It doesn't provide access to all the RDMA transfer modes, for instance. It implements a write by a remote read. It always pulls the data. And SMB chooses to do that, but SMB can also push the data with the push mode extension. NFS would require either a side protocol approach or a protocol change to do push mode. And so it's a little less flexible. It's bound by that legacy XDR. The reason for that, by the way, was compatibility with old code. The Sun engineer who worked with me had to protect fairly carefully his legacy code and didn't want to rearrange all the XDR code, which was literally all over the code, right? The receiver didn't even know where the data was in the packet until it got to that as it decoded. It serially decodes each element in the XDR strings until it finds data. And then it says, oh, there's no data here. I'm going to have to do an RDMA read, so that does an RDMA read. Really difficult. And not quite finally, the documents. The Microsoft docs, they're excellent. You're welcome. But they're quirky. They're written in a strange way, right? Must and may mean different things. They mean what Microsoft must do and what Microsoft may do. May basically means don't do it, right? It's not really a choice. It says Microsoft does not do this. You could. It's not illegal, but you're not doing what Microsoft did, so you're on your own. So they're quirky. However, they're tested and they're maintained, right? There's a test suite for every protocol in the corpus, and it's tested. So Windows doesn't ship without testing it, and you should too if you build an implementation. You should test it. Now, a test, quote, violation may or may not be a problem in your code, right? It just says you're not doing what Windows does, but they're tested. And they're open source test suites, right? You can download and do whatever you want with the Microsoft test suites. It's broadly implemented as a result. Successfully, we have a great SMB3 ecosystem. There's a perhaps even better NFS4 ecosystem, but doesn't have any of that stuff. It has IETF RFCs, which are fairly weighty. They're highly normative. It's always must, 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 must. And when something says should, it's like, well, there's a choice here, but you need to think it through, and we're not going to give you any guidance. The Microsoft docs give you guidance. They say Microsoft does it this way. The IETF docs don't do that when they say should, right? They say it's your choice. So it's more of a vague instruction. It's not a recipe for creating the protocol. It's a recipe for making the decisions to create a protocol. They're slow to change by design. You have to go through a whole IETF review process. You have to publish an RFC. You have to have 2 reference implementations. You have to have a lot of stuff. It's by design, but it's slow to change. And they're updated via full replacement. These things are 800 plus pages long. So is SMB3. But SMB3 is edited line at a time. Oh, there's a bug, and it gets fixed. And there's a log of the bug and errata and stuff. But the NFS RFCs change wholesale. It's something bis, or it's a whole new number. It's like You got to read 600-800 pages all over again. Not easy. And they're very informally tested. There's interop events. There's one coming up in May in Ann Arbor, Michigan. I went to the one in last October in Westford, Massachusetts, very near my home. And there's a PY-NFS testing client, an artificial client written in Python. But that's kind of it. You know, individual companies have created their own test suites. But there aren't a lot of tools to do this, to do testing of NFS4, in my opinion. It works, more or less because of the great flywheel of the market, right? If you're not in phase with that flywheel, you're going to get yanked in phase with it very quickly when you deploy your product. But there's nothing by design that created that. So I have some pet peeves, and I'm getting down on time here. I thought I was going to run under, but I might have to accelerate. SMB3's these are my pet peeves, okay? I should say my opinion only. There's a name perception. Everybody reads SMB3, and they read, oh, this is a Windows protocol. SMB3 is not a Windows protocol, right? It's much. Yeah, it's better than CIFS, okay. But still, that's a pet peeve of mine. I mean, I really wish we hadn't called SMB Direct. It's an RDMA framing layer. It has nothing whatsoever to do with SMB. But we called it SMB Direct because it enabled SMB to use RDMA. We should have slapped ourselves into sense before we did that. SMB3 is maybe a little too extensible. I talked about extensions elsewhere. You know, NFS doesn't have an FS control, for instance, right? SMB does. SMB has info levels. NFS has POSIX, right? It's very difficult to extend NFS. It's very easy to extend SMB3. It may be a little bit too extensible, right? We have Apple doing one extension. We have POSIX extensions doing another one. And, you know, you can do it without writing it down, and that's always risky. And so, you know, but it's extensible. FS controls, I've always hated this. They're limited to a 64K out buffer and a 64K in buffer. You can't transfer that via RDMA. You can't transfer bulk data via FS control. So it's hard to extend. You have to do reads and writes if you want to do bulk data, which means you have to abstract the read and write in interesting ways. Those are just pet peeves, things I'd love to fix someday. NFS4 has no truly asynchronous op. It has NFS error delay. It used to be called NFS3E jukebox. It was there because they literally had a jukebox, an HSM tape machine, right? And you'd access a file that it was offline, and it would have to go fetch the thing and hang the tape and spin the tape and read the file and put it in the cache. And it'd take 3 days or whatever. So it said, oh, that's too hard. You know, an RPC is like a subroutine call, right? It's either going to return or it's going to block. And if it blocks, well, how do we know that it didn't get lost? And blah, blah, blah. So they said, jukebox. Well, NFS error delay is still there in the damn spec, and it's getting used more and more. They even use it for op sequence now. And it's optionally used. I just realized this. I don't know why I didn't, but it's optionally used to indicate an in-progress request in the reply cache. It says, you know, jukebox or NFS error delay, we're already doing this job. It doesn't say we're already doing the job. It terminated your RPC to say, you know, come back again later. The client has to decide how long to wait and then to re-request it. And it's just, I can't think of any non-4-letter word to call it, but everybody seems to love it because it's easy, right? Oh, it's somebody else's problem. Give it to the client. The client can handle it. Great idea. It has a reply cache. You know, SMB has a reply cache too, but it's not as important in SMB. It's really important in NFS because it has those path name-based operations. You know, what if I did a rim or a rimdir, right? POSIX semantics there's a word that got lost. POSIX semantics are in the protocol caching, and they're kind of weak caching semantics. SMB has client-side and server-side caching in the protocol. And it's not really extensible. Okay, so am I going to draw a conclusion? Actually, I have 4 slides here. I'm going to try to do them in 2 minutes. SMB is the richer protocol. I can say that with confidence. It's extensible. It's got a much richer set of operations than NFS v4. It runs on more total platforms, right? It runs on Windows. That wins right there. But it runs on a whole lot of Linux, too. It's much more extensible, right? It's not future-proof necessarily, but you can adapt readily with SMB3. You can do the POSIX extensions in finite time, right? If you were going to do Windows extensions in NFS4, heaven help you. POSIX extensions are not enough. I'll mention that. NFS is the most faithful to POSIX, meaning Linux. Faithful. Faithful is good, right? I can count on it. It's faithful to me. I'm faithful to it. It runs everywhere Linux does. Oh, great. It's always there out of the box. It'll just work, and it will. NFS4 by itself won't change much, right? It'll do what it's doing, but it's not going to change in the future. It's pretty much a stable, well-established thing. But it's all about meeting the needs of applications. So my opinion, part one, stable and trusted, NFS4, stable and trusted solution for Linux. It's mature, will change very little. That's a good thing, a very good thing. All right? SMB3 is flexible and extensible. It presents more opportunity for growth. It can readily express diverse client needs. POSIX extensions are just the first of these. Growth, stability. Growth, stability. Pick. They're both stable. The biggest and best thing that could happen to SMB3 is for Windows to support the POSIX extensions. Overnight, the market for SMB3 would grow, right? Samba can do it, KSMB can do it, but if Windows did it, oh man, right? I think Windows already has the tools to do it. WSL already supports all these types of operations, and there's info levels and all this other good stuff for it. I'd love to see that. I'd really love to see that. I've told Microsoft this before, by the way. This isn't anything new. The second biggest thing is to expand the scope of Linux SMB3 applicability. Make it applicable to more applications, right? Applicability, application, those rhyme for a reason, right? Exotic workloads, I think, is an obvious one. HPC is really frustrated with NFS because of the POSIX semantics. If you stat a file in POSIX, the data that's in cache has to be synced to stable storage before the stat can return. They want the most current version of stable data to be returned in the stat call. And so NFS, which is forced to cache data like crazy for performance, has to flush all this stuff over the network every time somebody calls stat, right? All I wanted to know was the size of the file, but you had to flush it before you could tell me that. Drives HPC applications crazy. HPC also strides workloads, right? They take a row of a matrix and they want to send it to one device. They take another row and want to send it to another. So they read the file in strides. That's a very non-POSIX workload. And it drives them crazy, so they find all sorts of ways to work around it. File system optimizations like caching and stuff like that. The SMB protocol expresses this, but does the API and does the file system, how do we bubble all that up so where an application can actually use it? Minimally with new info levels and FS controls, ultimately with new SMB3 extensions, right? You can prototype it with info levels and FS controls, and if they work, you can standardize them. It'll take time, though, because even if you do that, applications change slowly. APIs last forever, just like protocols. Part three, now I'm getting really out there. It's not silly to consider SMB3 as a PNFS layout. PNFS already lays out NVMe, it lays out all these odd places for things, right? They say, you can get the blocks of the file on this block protocol, if you follow my layout. You could do that with SMB3. So NFS could encapsulate SMB3 or could direct some application to SMB3 in really interesting ways. For SMB3 extensions to refer to NFS, maybe SMB can encapsulate NFS or somehow point at it. SMB3 doesn't really have a PNFS style thing. There is in the clustering a PNFS style service, but that's not exposed, it's not public. It's also not impossible for SMB3 to tunnel other traffic, right? We tunnel IPC, we tunnel whatever. All these things are crazy talk, right? Do this later, but my mind wants to go there. I think it's a really interesting wrapper protocol. That's it.